All right, let's talk about something that literally moves our world. We're talking about the stuff that powers our cars, our planes, our ships. But what is petroleum, really? We're about to go on a wild ride, from deep inside the Earth's crust all the way to the fuel in a rocket engine to figure that out. So, first things first. We all think we know what petroleum is, right? It's the stuff that makes things go. But what does the word petroleum actually mean? Turns out, the answer is kind of hiding in plain sight in its ancient roots. And believe it or not, it tells us a huge part of the story.
Okay, so check this out. The word itself is a giant clue. It comes from two old Latin words, petra, which means rock, and oleum, which means oil. So put them together and what do you get? Petroleum is literally rock oil. And that name is perfect, right? Because that's exactly where it comes from. It's formed over millions and millions of years from all this ancient organic stuff, just getting crushed deep down in the earth under unbelievable heat and pressure.
So we've got the name down, rock oil. Pretty cool. But what is this stuff actually made of? I mean, on a chemical level, it's a super complex mixture for sure, but lucky for us, chemists have come up with a really neat way to break down its core components.
And it all boils down to this simple four-letter acronym, PONA. Seriously, that's it. You can think of PONA as the fundamental recipe, like the chemical DNA for pretty much all crude oil. Every single drop of crude out there has its own unique blend of these four things.
So you're probably wondering, what the heck is in this PONA code? Well, let's break it down. The P stands for paraffins, O is for olefins, N is for naphthins, and A is for aromatics. These are the four main families of hydrocarbons that make up crude oil, and trust me, each one has its own totally distinct chemical personality. Let's get to know them.
First up, we've got paraffins. Now these are what we call saturated hydrocarbons. All that means is their carbon atoms are all linked up by these really stable single bonds. You can think of them as the calm, predictable, straight and narrow members of the group. And it's that stability that makes them such great clean-burning fuels, like propane and butane.
Next up are the olefins, and these guys are pretty much the polar opposite. They're unsaturated. What that means is they have at least one double bond between their carbon atoms. Now you can think of that double bond as a little bit of an unstable connection, which makes them way more chemically reactive. And that's perfect for when you want to transform them into other stuff like plastics.
Then we've got the naphthenes. Now these are kind of like paraffins. They're saturated, all single bonds, but here's the twist. Instead of forming straight chains, their carbon atoms loop around and connect into one or more rings. It's this dense circular shape that makes them a really crucial part of high-quality fuels. We're talking about stuff like jet fuel.
And last but not least, we have the aromatics. Oh yeah, these are the really special ones. Their defining feature is this thing called a benzene ring. It's this incredibly stable 6-carbon ring structure. This unique shape is awesome for boosting the octane in gasoline, which helps stop that annoying engine knocking. And yep, you guessed it from the name, they often have a pretty distinct smell.
Okay, so we've got this complex PONA cocktail, this recipe for crude oil. But, and this is a big but, here's the fundamental problem. In its raw, natural state, crude oil is, well, it's pretty much useless. You can't just pump this thick, black sludge right into your car. It just doesn't work that way.
And this right here is the central challenge, isn't it? On one hand, you have the problem. This complex, impure, totally unusable gunk. And on the other hand, you have the goal, all the super valuable products that actually power our lives. Gasoline, diesel, kerosene, you name it. So the big question is, how do you get from A to B? How do we bridge that gap?
Well, the solution is a massive, and I mean massive, industrial process called refining. It's basically an extreme makeover for crude oil. Inside a refinery, they use this incredible combination of intense heat, crazy amounts of pressure, and special chemicals called catalysts to just break down that crude oil, sort out all those PONA molecules, and then rearrange them into something we can actually use. This whole transformation basically happens in 4 main stages. Think of it like a recipe. First, you have distillation. That's where they boil the crude to separate everything by weight. Then comes conversion, which is where the real magic happens. They chemically crack and reshape molecules to make more of the good stuff. After that is treatment, which is basically the cleaning step, getting rid of nasty impurities like sulfur. And finally, you have blending, where all these different refined bits and pieces are mixed together to create the final products we see at the pump.
So there you have it. We've traced this incredible journey from a simple name, rock oil, all the way to its secret chemical code, PONA. And we figured out the fundamental challenge,
turning a messy, unusable sludge into something priceless. We know the answer is refining, with its 4 key steps. But that just brings us to the biggest question of all. How do we actually do it? How do we turn this rock oil into the products that literally move our world?